Next up, we have Brittany Stewart. Brittany is a graduate student in Dr. Rob Orchard's lab in the molecular microbiology department. Her hobbies include petting dogs, riding horses, and participating in public speaking events where she can be an anxious mess in front of large crowds of people. Her talk is entitled Flipping the Script, Phospholipid Distribution as a Mechanism of Host Defense.
2020 was an unprecedented year in more ways than one. For all of us, it meant tackling loneliness and isolation. For many of us, it meant becoming stay-at-home elementary school teachers. And for some of us, 2020 was the first time that the impact that viruses have on both public health and the global economy became apparent. Viruses are a natural and essential part of life, and for the most part, humans do a pretty good job of coexisting with these microbes. However, as 2020 reminded us, humans and viruses are in a constant arms race. Understanding how viruses replicate and how our own cells combat viral infection is important for developing antiviral therapeutics and vaccines. Understanding how viruses enter cells is especially important for this. In my work, I aim to understand how lipid asymmetry in the phospholipid membrane affects viral entry. The plasma membrane is composed of phospholipids arranged in a bilayer. And within this bilayer, the lipids are arranged asymmetrically, making the two sides of the membrane similar but slightly different, just like the two sides of a hamburger bun. Proteins known as flipases maintain phospholipid asymmetry. In some cellular events, such as apoptosis, proteins known as scramblases can permanently disrupt lipid asymmetry, resulting in exposure of phosphatidylserine, or PS, on the outer leaflet of the cell. This marks the cell as a dead cell. I've shown that lipid asymmetry is important for viral entry. I've shown that flipases can be proviral, whereas scramblases can be antiviral. And we think that this is linked to the externalization of PS, which is interesting because it suggests that maybe viruses can detect and thereby avoid infecting dead cells that are unable to support viral replication. There are cases, however, in which cells can transiently express PS on the outer leaflet of the membrane, and we think that evasion of viral infection may be one of these cases. And so in this scenario, we would have healthy cells that have normal lipid asymmetry and dying cells that have permanently disrupted lipid asymmetry. And then we have an intermediate, which are these living, clever cells that are able to temporarily put PS on the outer leaflet of the cell and play dead. Just like you might avoid this ugly little hamburger at a buffet, the virus would then avoid these cells during infection. If this is the case, we will have uncovered a new branch of immunology and a new mechanism of host defense. 2020 reminded us that we always have to stay one step ahead of viruses. This work has the potential to allow us to do just that. Thank you.